But first, it's very cramped in here, but that was a katana, a Japanese sword that I drew, and then despite the limited space here, I did the chiburi, which is the blood shake, and noto, which is the sheathing of the katana. So that's not what I wanted to talk to you today about. What I wanted to talk to you today about is the burning question of our time, which is Midori's sleep score better than mine? That's what I mentioned in 7.1, you may recall, and we're ready to investigate that question with our inference procedures. Okay, so let's get started. So the research question again is Midori-san's sleep score better than mine? Midori is the name of my wife, Midori Snyder. She's an author. She's not Japanese, but she has a Japanese name. So Midori-san. So that's the question, and we can answer it with data from our Fitbit pedometers or step trackers. Let me show you those. Yeah, they're charging right now. So I've got on my left side, I've got Midori-san's. They're identical, actually. This is her tracker. It's called a Fitbit Inspire HR. That's hers. And I don't want to mix these up. And here's mine. So they're identical. And whoops. And they track obviously steps per day. I was going to investigate the question: who moves more, who steps farther, or who has more steps of a day on average. But Midori-san is also a knitter for our grandchildren, and a shortcoming of the pedometer is that it counts the wrist strokes of her knitting as steps. And so I'll get, 9,000 or 10,000 steps a day. And I say, I think I beat you. And she said, I got 22,000. And a lot of those are stitches. So I didn't like that, the measurement error that would creep in, and I would lose too. So I didn't want to do that. Anyway, so those are the instruments of measurement: the Fitbit Inspire HR pedometer. The app also sort of classifies or estimates a person's sleep score. And it's a combination of number of hours of sleep. The quality of sleep is measured by REM sleep, rapid eye movement sleep, deep sleep, light sleep, and hours or minutes awake. And then they classify sleep scores depending on those variables. 60s and below is poor. 70s is fair, 80s is good, and 90s is excellent. So let's proceed to the measurements then. So I'm just going to go through the steps that retrace my steps of what I did to answer our research question. Is Midori's sleep score, Midori-san's sleep score better than mine? So I looked at her app and my app on our phones, and I recorded the sleep scores for the last 41 days, for which, there was a measure of an estimate of sleep score for her and me on the same date. So I went back 41 days, from 8 December to about 3 February. She just got her Inspire HR right around late November, early December. I can't remember exactly when, but so 41 days, 41 measures. Then I decided to randomly, so that's the population. I defined that as the population, the last month and a half of sleep scores on the same night. And then I randomly selected 20 sleep score dates. Okay, and I'll show you this on the calculator in a minute. I wanted to run a comparison of two means, two different means, and run a hypothesis test and calculate a confidence interval. But first, as you know, I need to check the conditions to see if it's warranted to proceed with these inference procedures, the two-sample t-test. So let's verify these assumptions, or see if they are supported. There are assumptions, the three. So let's just go through them, and I'll show you two again. That they are all supported. First of all, I mentioned that I picked or I randomly selected 20 out of those 41 sleep scores. So that it was randomly selected. So we can check that one. Check. Is the data a large count, meaning greater than or equal to 30, like the central limit theorem dictates? And no, I don't have 30 observations. I have 20. But I took a look at the distribution of data, both her and my sleep scores, and it looked there's one, as you'll see, there's one outlier in Midori-san's sleep score, and so, but I felt that be cautious. The textbook always say be cautious in applying inference procedures in this case, because there was one outlier in her data. There weren't any outliers in my data, and it didn't depart substantially, either her sleep scores or mine, from a normal distribution. And I'll show that to you in a minute. What about the sample size being less than 1/10 of the population? Well, if you take the population of all our sleep scores, obviously 20 observations is well less, or much less than 10% of that. So that one is verified as well. So it seems safe to proceed with caution because of that one outlier. But as I said, I don't find huge departure from normal distributed data. So here's what I did. This stuff is in there. These data observations are in my calculator. I hope you can see them here. But we'll just go to list. And okay, so list one are the, let me see, just scroll over there. List one is Midori-san sleep scores. And again, 70s fair, 80s is good, 90s is excellent, so on. So we'll just scroll down to show you that it's 41. Yeah, 41. List two are my sleep scores on those same evenings. And then what is list three? I don't know what I did in list three. Oh, I know. I sequenced the dates. Okay, I gave so that 41 in list 3 means the 41 observations. Then I took a simple random sample using the calculator, and I can show you that in case you forgot or so. And I picked 20. So there's Midori-san's randomly selected dates, and the same date, the same sleep score on those dates randomly selected. So let me just show you, remind you quickly how to take a random sample of digits. So to get my 20 randomly selected dates, you go to Math, scroll over to Probability, and then hit 5, the random integer, and the lower bound was 1, the upper bound was 41, and n is going to be 20 because I want 20 randomly selected dates. I gotta I made an error. Hang on, let me just clear this out. Quit. clear. Now I go to math. Sorry about that. I was going to paste it in there. So here we go. And boom. So there are the randomly selected dates. The 41st date, the 12th, I'll ignore that because it's repeat, 5, 3, 30, and so on. Okay. And I can do it again if like I only come up with 19 observations, I can do it again. So there's second or 5. 5, I guess, is in the first list. But anyway, you keep hitting that until you get your 20 observations. But I got it on the first try. There were, I don't think there were any repeats. I can't remember. Anyway, so now I have my randomly selected data. Let's look at the data, see if it's, as I claimed, reasonably normally distributed. All right, let's just want to show you one more thing. So list 4 and 5. So list 4 are the 20 randomly selected sleep scores for Midori-san. List 5 are the 20 randomly selected sleep scores for yours truly. So let's take a look. Let's quit out of here. We'll go to second var or second Y. And I think what I've done, yeah, so I did a box plot for Midori-san sleep scores, and in plot 2 up here, I did, as I recall, yeah. So here are my sleep scores in a box plot form, and so those are side by side. I think you'll be able to see those. So the blue one is Midori-san's sleep score. The red one is mine. We could trace that, but there's that outlier. Let me scroll over to. She had a bad night. A sleep score of 50. Minimum was 69. First quartile 71. Median 75. Third quartile 81, and maximum of 91. Ugh. All right, so my sleep scores respectively. Minimum was 55. 67 first quartile, medium of 72.5, third quartile 75.5, and maximum of 83. So eyeballing them, it looks like she's doing better than me in the sleep score area based on that random sample. One other test of normalcy that I want to show you. So I went back to second Y just to test this, and I'm going to go up to second plot and turn that off. That's my score, if you recall. So turn that off. Back to Midori-san sleep score. Oop. There we go. And now, instead of a box plot, I'm going to do the normal quantile plot of that data. And you'll recall what we're looking for is a 45-degree lower left to upper right, which is plotting the standardized score of that data against the original data. So let's take a look. So there's that outlier, but you know, the rest of the data, if you sort of block out that, it looks pretty good. Now let's do the same for mine. As I recall, mine was even more normal, as it were. So we're going to turn her plot off. And we're going to go up to mine, turn mine on, and then scroll down and pick the normal quantile plot. Enter, and then let's take a look. Yeah, so that's why I say I looked at box plots and I did a normal quantile plot, and I conclude that the large count and normal distribution of data seems warranted. In other words, the data, despite that one outlier, Midori-san, I mean, that we should mention that in reporting our results and say, you know, we're going to proceed with some caution in applying these inference procedures. But I feel it's safe, based on what I've shown you, to proceed with both a 2-sample t-interval and a 2-sample t-test comparison of two means. So here we go. So I wanted to show you the notation of the research question here. So the null hypothesis is that the sleep score of Midori-san is equal to the sleep score of me. Okay, and the alternative hypothesis is that they're not equal, that those two mean sleep scores are not equal. Now, another version of the alternative hypothesis could be that the sleep score of Midori-san was greater than the sleep score of Steve. Okay, but that's a one-tail test, and I'll show you that, but I don't want to do that. I like two-tail tests, non-directional tests, because and this might be an extra credit question, it asks more of the data in terms of establishing a threshold of, either rejecting or fail to reject the null hypothesis. So I'll use both. I'll show you both, but I'm going to proceed with the two-tailed test. Okay, so let's apply the inference procedures. Again, the conditions warrant it, so I'm going to do a two-sample t-test comparing two means, her sleep score mean and my sleep score mean, and then I'm going to also construct a two-sample t-interval. All right, so let's do so you go to stat, you go to, scroll over to tests, and then I think it's number 4. I want a two-sample t-test. Why t-test, by the way? And in your reading, you'll learn all about the family of t-distributions. There's one for every degree of freedom. And because I had less than 30 observations, in my data sets in both, I felt that a t-test would be more accurate. Z-test assumes normal distribution, 30 observations or more, and so on, blah, blah, blah. And Z-test also knows the standard deviation of the distributions. A t-test estimates the standard error based on the data itself. So 2 reasons why I'm using the t-test. So let's scroll down there, hit enter. As you can see, I'm using data, not stats. And I stored, if you recall, Midori-san's in list 4, mine in list 5. You have the option of doing a two-tailed test or a directional test, and we can do that later. Anytime I get asked, do I want to pool the standard error, I say no, because I want, if there's greater variation in mine than hers, I would like to know that. So I don't recommend using pooled data. All right, so let's, ta-da, drum roll, please. Oh, my phone is ringing. Pause. I had a phone call right in the middle there. So let's have that drum roll again so we can see the results of the inference test. Okay, here we go. This is, again, a two-sample t-test inference procedure. Snyder score list 1, Hessler score list 5. Snyder score list 4, Hessler score list 5. Two-tailed test, because it asks more of the data, calculate. Boom, there are the results. We got a t-test statistic of 1.67. Very importantly, we have a p-value of 10%, which is greater than our alpha level. I should have specified the alpha level. Superior pedagogy by negative example. But, my alpha level was 0.05, meaning anything less than 0.05 in terms of a p-value would be sufficient grounds for rejecting the null. The degrees of freedom are 35. The average sleep score for Midori-san was 75.4. For my sleep score, it was 71. We got to get, melatonin, or we got to get better sleep scores. They're fair, but on average, but I'd like better sleep scores. There are the standard deviations of the two distributions and a bunch of other things, but that's what we're talking about. Now, let's go ahead and just, while I have you, calculate the confidence interval for a two-sample means test. Here we go. We're going to and I think it's all the way down past 9, as I recall. Yeah. 2-sample t-interval for the difference of two means. So in other words, what the calculator is going to do is to take her sleep score, subtract my sleep score, and have that difference, and then plot those. So the distribution is the distribution of differences between those two sleep scores. So let's go ahead, and the data is already in there, list 5. The confidence interval with an alpha level of 0.05, obviously confidence interval is 0.95. No, for previously stated reasons, to pooled variance and standard deviation. So drum roll, please. Fascinating. All right, look at that, guys. The difference, there's the t interval, the t confidence interval for the difference between two means. And you can see plain as day that the value of 0 is included in that interval. All right, again, degrees of freedom 35, our respective sleep score means, and so on. But if the interval in the difference between two means includes the value 0, that means that we cannot reject the null hypothesis. We fail to reject the null hypothesis. Let's go back and draw that. So let's just give some room here. So another way of writing that null hypothesis would be sleep score of Midori-san minus sleep score of Steve equals 0. Okay, and the alternative is that the differences would not equal 0. But we can't reject the null, right? Because the value of 0 was in that confidence interval. All right, guys, so what do we conclude in the context of this problem? What do we start with? Here it is. It's on a post-it note. Is Midori-san's sleep score better than mine? The data does not support that. We cannot reject the null. So I would say no. There's really no difference based on this on those 20 randomly selected dates. There's really no difference between her sleep score and mine. So I hope that clarifies a little bit more about applying t-test procedures, both the comparison of two means and a 2-sample confidence interval. All right, guys. God bless.